Hey everyone, welcome to a kinematics help video, and this one we're going to be looking at what's called the braking car problem, or as I like to call it, don't hit the deer, or the moose, or whatever has just jumped out in front of your car. So we're going to highlight the key information. Our car is traveling 80 kilometers an hour, and we see a deer jump out in front of us, and it's approximately 50 meters down the road. We see the deer, we immediately apply our brakes, and it slows us down at a rate of -6 meters per second squared. That's our acceleration. The question is the car able to stop in time? Is the deer safe? Don't hit the deer. The equation that we're going to be using in this type of problem is called velocity final squared is equal to the velocity initial squared plus 2AD. And I'm going to take a moment and just write out what these different variables mean just so that everyone knows it. The VF is the velocity final. So when we stop or whatever it is at the end of the situation, what is the speed of our car? Hint, hint, if we're trying to brake, you could probably figure out what it's going to be. VI is the velocity initial. So what do we start at? And do keep in mind that in this equation, the velocity initial has to be written in meters per second. So we're going to have to deal with that here in a moment. A is the acceleration. The acceleration is provided, and that has to be in the units meters per second squared. And the last thing that we're looking at here is D, which is the distance that it takes to finish this problem, and that's measured in meters. Now we know all of our variables. We have 3 of them. We're looking for the 4th. Let's go ahead, scroll down, and we'll start filling in what we know and make sure that the deer is safe. So we have to start by turning those kilometers per hour into meters per second. Anytime you have a question like this, get into meters per second. Our 80 kilometers an hour, to convert that into meters per second, we're going to have to divide by 3.6. Kilometers per hour to meters per second, divide by 3.6. That gives us 22.22 meters per second. Now we know our velocity initial, our velocity final, all the little clever cupcakes out there, you already figured it out, it's 0, because in the end, the car has stopped. So we have our velocity initial, we have our velocity final. 0 equals 22.22 squared plus 2 times our acceleration, which was -6. Mind that negative. I've seen that mistake too many times. Multiplied by D. Great. We're going to multiply that 2 by the -6. It gives us a -12D, and we're going to bring that right over to the other side. 12D is equal to, we're going to go ahead and square that number, 493.83. This is no bad. Divide by 12, divide by 12, fingers crossed. Distance equals 41.15 meters. Whew. I was worried there for a moment. My students will be worried. You don't know what's going to happen in a question like this. But in this question, the deer is safe. And this is an example of how we use the equation velocity final squared equals velocity initial squared plus 2AD. Watch for this style of question anytime no time is provided. I hope this was helpful. Looking forward to seeing you next time.